In this video, we're going to explain about ATM machine model using Finite Automata. The first method is model representing cash withdrawal. First, when we insert ATM card into the ATM machine, it will ask to enter the PIN. If the PIN entered is incorrect, it will return back to the previous node. If the PIN entered is correct, it will move to the next node. Then we have to select the withdrawal option. Once the withdrawal option is selected, it will check the total amount in the account. If the amount entered is insufficient in the account, it will return back to the previous node. If the entered amount is sufficient in the account, it will move forward to the next node and withdraws the amount. Then we have to remove the card from the ATM machine. The next method is model representing cash deposit. First, when we insert ATM card into the ATM machine, it will ask to enter the PIN. If the entered PIN is incorrect, it will return back to the previous node. If the entered PIN is correct, it will move to the next node. Then we have to select the deposit option. Once the deposit option is selected, it will enter into our account and we have to insert money that has to be deposited into our account. Then the card has to be taken out from the ATM machine.
What's the issue? I'm not able to understand some related to DFA, a substring not ending with ABB. Is it? Yeah. Wait. This is similar to the one which ends with ABB. Are you aware of that? Yeah. Okay, so then the task is simple. You understand this very easily. So instead of me practically teaching you by writing, why don't we imagine an activity? Yeah, that's great. By writing. Yeah.
String is ABB?
Yes, you're right.
So UBA, IBB.
Perfect. Saida, can you guess the alphabet set required and can you represent it?
Yeah, let me try. So the alphabet set is denoted by summation, which is basically equal to A, comma B, where A is U and B is U.
That's perfect. Let's go to the next step.
Yeah.
So Saida, our next step is the skeleton wheel. Here are the states. This is the start state Q0, after which is Q1, state Q2, this is the final state Q3. So Saida, as we know the minimal requirement is ABB, from the start state Q0, we have the first input A, after which is B, which goes to Q2, and finally it goes to Q3. So Saida, since you understood the concept, can you show us the other transitions?
Yeah. So this is the skeleton DFA.
Okay.
So it tells that it is not a substring not ending with ABB. So when I do a transition from Q0 to A, it goes to a state Q1. When I do a transition from Q0 to B, it's a self loop. And from Q1 to A, it's a self loop. Q1 to B goes to the state Q2. Q2 to A comes to the state Q1. Q2 to B goes to the state Q3. Q3 to A comes to the state Q1. And Q3 to B goes to the state Q0.
Okay, so this is the string ending with ABB, right?
Yeah.
Do you remember our question?
Yeah, it was a substring not ending with ABB.
Yes, Saida, for the substring which is not ending with ABB, this is how our representation will be. That is, the final state Q3 will not be a final state any longer and all the remaining states will become the final states.
Okay.
So this is our final DFA representation. So Saida, are you happy now?
Yeah, very much. Thank
Did you learn
so
things
much.
well?
Yeah, a lot. Thank you so much.
No
Aishwarya.
problem.
This is a demonstration of DFA string processing using Java Swing and regular expressions. So basically what we are going to do is, for a given DFA, we check whether the given input string will get accepted or rejected. So let us consider the first DFA with the language to accept even number of A's. So if I give the input as even number of A's and then validate it, the string would get accepted. But if we make the number of A's to be odd and then validate it, the string is rejected. Similarly, to accept string beginning with 0 followed by odd number of ones and ending with 2. So 0 followed by odd number of ones and ending with 2. If I validate it, the string is accepted. But if I make the number of ones to be even and then validate, the string would get rejected. So the next one is to accept the string ending with AB or BA. So ending with AB or BA. In both the cases, the strings are accepted. The next one is to accept the string ending with ABB. If I validate it, the string is rejected because our input string does not end with ABB. So if we add another B and then validate, the string would get accepted. And the last one is to accept a string ending with BAB. So if I validate it, the string is accepted. Now let us look into the code. So first we have to import all the necessary packages that are required. So the first one is java.x.swing package, which is used for implementing the Java Swing components such as JFrame, JButton, JLabel, etc. And the next one is AWT and AWT.event packages, which are used for implementing the AWT components and also the action listeners. And the last one is the regex package, which is used for implementing the regular expressions in Java. So first we are going to create a public class called frame1, which will be implementing the action listener. The action listener is used to handle events triggered by user interactions with the window application. So inside the class, we have a constructor called as frame1, and inside the constructor, we have created a new JFrame called as frame. And we will be listing out all the components that we want to display in this JFrame. So after listing all the components, we will be adding it to the frame by using frame.add function. After this, we find an action listener which is linked to the next button. So when we click on the next button, it will take us to the next frame. So when we write frame.dispose, it is used for closing the current frame, and f2.setVisible is used for going to the next frame, which consists of a different DFA. So now we come to the main logic part where we are going to be validating the string. So we have an action performed which is triggered when we click on the validate button. So first we get our input from our text area that we had defined earlier and store it to a variable called as text. After that, we will be writing our logic for our regular expression. So the caret symbol at the starting symbolizes the starting of the regular expression, and dollar symbol represents the end of the regular expression. So this logic is used for saying that it will be accepting empty string or even number of A's. After writing the regular expression, we are going to compile the regular expression and match it with our input text. If it is a match, we are going to be displaying that the string is accepted. Else, we will be displaying the string is rejected. So finally, we come to the main function. In the main function, we are creating an instance for frame1, which is going to be used for the window application. So this is the code for implementing the DFA string processing in Java. Thank you.
Let us consider an example, that is design a DFA with 0, 1, accepts those strings which starts with 1 and ends with 0. So the given data is 0 and 1. So L is basically the number of outputs which starts with 1 and ends with 0. So the minimum length is 2. So the number of outputs would be minimum length plus 2. So let us see how the transition of the transition diagram works. Thank you. Let us take three states A, B and C, where A is initial state, A on 1 goes to B, B on 0 goes to C. We need to satisfy the condition the string should start with 1 and ends with 0. Let us take a string 1 0, where the given diagram shows that 1 0 satisfies the given condition. Let us take another string 1 0 0, where on the diagram 1 0 a self loop on C 0 gives us a given condition, satisfies the given condition. Then take another example 1 0 1 0 0, so that we can see that 1 0 a loop from C to B 1 0 0, satisfying as the given condition 1 0 1 0 0.
Thanks so much.
Hello everyone, this is to present the idea of conversion fit to DFA. Here this person Lizzie is represented as initial state. She is using her computer, this will be taken as the next state. If we take this as a middle state, she won't be able to do other tasks. So it will become self-loop, and she won't reach the destination. Then if we add another state as middle state, in which she is watching TV, here also she won't be able to reach the destination. So it also becomes self-loop. In this case the destination is not reached, therefore we have to eliminate these states, and we have to reach the destination. In this case, we eliminate those two middle states using state elimination method and then add a state through which we can reach the destination. Here Lizzie is working hard, and this will become our middle state after state elimination. It will have two conditions. First, if hard work is successful she will reach her destination. If it is a failure it will become self-loop, and she will work hard to reach the destination. As we can see, this will be the state diagram of both the cases. In case 1, we have both middle states which are eliminated. In case 2, using state elimination, and one state is added to next state through which we can reach the destination.
Thanks so much.
Hello everyone, I'll be showing the demo of our project, regular expression matcher. So before going to the demo, first let us know what is regular expression. Regular expression, commonly abbreviated as regex, provide a concise and flexible means for matching string of text which adhere to specific patterns. So this is the simple definition of regular expression. I'll show the simple demo. So let us consider this regular expression, and if we match a string, okay, I'll give a simple string here, and if you press compile it says result is matched, and if we give something which is wrong, and if you press compile again it says result is not matched. So this is the simple example of checking the regular expression. Okay, these are the team members.
Thanks so much.
Hello everyone, today we are diving into Pushdown Automata and how it works using our interactive website. Imagine Pushdown Automata, or PDAs, as smart machines that can recognize patterns in strings. They are like the brains behind checking if a sentence follows a certain structure or not. They are super handy in computer science for understanding languages, especially for those with rules like for every A there must be a B. In our website, we made learning about PDAs fun and easy. First, you'll find a friendly explanation of what a PDAs are and why they matter. Then jump into our interactive demo where you can see a virtual PDA in action. Let's say you enter a string as AAA and BBB in our PDA. It will happily accept it because there are the same numbers of A's as B's, just like it should be according to the rules. If you try something like A, B and AB, it will say nope because it doesn't follow the rules. Behind the scenes, a PDA works with something called 7 tuples, which are like its instructions. This includes things like what to do when it seems certain symbols and how to move between different states. It's like a recipe for PDA to follow when it's checking strings. Our website is here to make learning about pushdown automata simple and enjoyable. So come on in and explore the world of PDAs with us. For more information about PDAs, check out the description link for this website. Happy learning!
Welcome everyone. In this video, I'll guide you through the step-by-step process of visualizing pushdown automata using Python code and the powerful medium of dot code. So first we have the Python code for the pushdown automata where we define the states, and the Python code will define the our pushdown automata and the stages of visualization. So in this we'll get the output. This output is important as we need to paste this output in the dot file. So this output that we got here, this dot code, we need to create a dot code representation of a pushdown automata. This dot code will provide a graphical representation of automata stages and transition. So we need to simply copy this. First we'll copy this code. We'll simply copy paste the generated dot code into a new file. This file will serve the input of our visualization tool. So here we are given the code and automatically it will generate the state. Yeah. Now we have seen the visualization tool that we see the stages. As we run the code, the visualization of the pushdown automata we can see. We pay close attention to how the stages and transition based on the input of the stack operation. This dynamic visualization will depend on the output and the stages that we have given in the Python code. So we can see how the transition is there. You can see the stages. So we'll see one more example of the same where we have taken a different stages and different transition so that we can see how the transition is different in different whatever the input that we give in the code. So this is the second code which we have here. We have stages and transactions. Now same thing as we did in the previous one, we'll similarly get one output, and this output need to be stored in the dot file so that we can copy paste it, and we'll put the output in the doc code, and then it will generate the same. So we'll simply copy paste the generated dot code. Here we'll simply copy paste it and just wait, and so that it will convert. So now you have seen the different, we got a different diagram for this, and the diagram shows the stages and the transition. This shows this tool shows the pushdown automata, allowing us to see the structure and the state transition in the diagram. So it is a diagrammatical representation of the pushdown automata. So by the following steps and Python code dot code, we have seen how we can generate the diagram of the transition of the PDA, and we can learn how it moves and what are the stages and the transition. Thank you so much. Please like.
Hi guys, welcome to my channel. So, today we are gonna make a working website on Lexical Analyzer. We are gonna use HTML to get a working lexical analyzer. This is the code required to get the lexical analyzer in HTML. We are using very basic HTML code to make the website, as you can see. Now let's see the output, what we get after saving the HTML code. So, this is the website that we got that takes in the values or set of statements that we give in the box. Let's try E equals to MC square and click on Tokenize button. We get the following tokens. Now, let's enter R equals to B plus C minus D multiplied by B and divided by E. Then click on Tokenize. So, we get this as the output. Thank you for watching.